So in this video, we'll discuss electric field strength at various points on the axis of a charged sphere, but it is non-conducting. In the previous video, how it will be if you want to know, and if it is a conducting sphere, then how the electric field strength varies at different points. You can check the previous video. And here we are taking a charged non-conducting sphere. So in case of a charged non-conducting sphere, the total charge will be distributed throughout the body. Say here q charge is given and origin at point P, what is the electric field intensity, that will see. So here we can assume the point that is taken is outside of the sphere and it is greater than its radius. At that point, at point P, the electric field intensity we can assume as due to a point charge or the charge, total charge concentrated at O. Okay, so you can apply Coulomb's law here. So one important point here we can write is, in case of a non-conducting sphere, charged sphere, the total charge is distributed throughout the body. So here case 1 will see what is the case 1, the point on axis at greater than radius of the sphere. So E, the electric field strength at that point we can write as K Q by x square. Along that vector, along the axis, the unit vector is x cap, then you can write vector notation E bar is equal to kq by x square into x cap. So here k is 1 by 4 pi epsilon naught. So second point, let us take the point on surface of the sphere at point P, will take at this point on surface, okay, that is at a distance r. So in this case also we can assume same as assumed in first case. So here x is equal to r, therefore electric field intensity or electric field strength on the surface of the sphere is kq by r square, we can write. I take only magnitude here. Then now the third case, this is very important. What is third case is x is less than r inside the sphere. So here 0 is less than x less than r, I can write. That means what? Not at center, not at the center of the sphere, greater other than the center of the sphere, and inside the sphere, what is the electric field? So here electric field will be there, electric field is present inside the sphere because charge is present. Charge is distributed throughout the sphere. Let us see that. Here we reach it at this point P at a distance x. We need to find electric field strength at this point. So what we can do at this point, we can construct a sphere of radius x sphere, and that sphere also consists of some charge. Of course, this charge is not equal to whatever the charge that we took q. So say here the charge will take as q inside charge, the charge inside it. So whether you take the first case or this case, the property called charge density rho, charge density is what here we'll see. Charge density of a given sphere rho is equal to q by 4 q by volume, that is 4 by 3 pi r cube. So here what is the charge density of this part which has radius x? The charge density will be same. That means what? The rho value you can write q by 4 by 3 pi r cube, and also you can write q in terms of that charge, inside charge, divided by 4 by 3 pi x cube, because the volume of this sphere is, the radius of the smaller inside sphere is x, its volume is this. So from this what we can write, q, the charge inside, see here we can cancel 4 by 3 pi, 4 by 3 pi, we can equate both these two things, and q inside, the charge inside is q x cube by r cube. So therefore the electric field intensity inside is equal to k q inside divided by distance square. So there also, see here also it is a sphere having some charge, and we can assume the total charge at center and at a distance x we are measuring. What is the electric field intensity direction? This is the electric field intensity direction. Some e dash we can write. So k q in will substitute from here, q x cube by r cube into already x square is there. If you cancel it, you will get k q x by r cube. That is inside. So it's a very interesting point we got here. We got inside charged sphere, charged non-conducting sphere, the electric field intensity is directly proportional to x. See here, because remaining are constants r, q, everything. Outside it is varying inversely proportional to square of the distance between them. So now we'll see how the electric field intensity is varying using a graph. On x-axis, let us take the distance. On y-axis, electric field strength. So at origin, x is equal to 0, and that fourth case also we should write. At x is equal to 0, at origin, what is the value? What the value of electric field strength is 0. Okay, because if you see formula, E equal to k qx by r cube. So this is where x is less than r. This is x is equal to 0. X is equal to 0, that is at origin. And another equation also will write E equal to kq by r square when where at x equal to r. What is the fourth equation? Kq by x square where when x is greater than r. For these four cases, we will draw the graph. At x equal to 0, at origin this is 0, and somewhere here we'll take x is equal to r. So x equal to r is the maximum. If you observe all the four equations, this x at x is equal to r, it is maximum. And between from x is equal to 0 to x is equal to r, what is happening? It is proportional. See, from this equation, E is proportional to x. So linearly it is varying. So x is proportional to E is proportional to x here. Electric field intensity is varying linearly. And here it is maximum. At x equal to r, it is maximum. Once the surface, the sphere surface is crossed, that is greater than the radius of the sphere, then it is so inversely proportional to x square. So this is how the electric field strength varies along the axis of a non-conducting sphere. Okay, if you have any doubts, you can write in comment section.